This is the reason why the United States Navy has spent 50 years struggling with warships that melt, crack, and dissolve in the open ocean. For half a century, the pursuit of speed and the need to carry heavy electronic sensor suites led naval architects to embrace aluminum alloys, and that decision came at the direct expense of structural resilience and combat survivability. Post-war naval technology advanced rapidly, but the heavy electronic instruments required for radar and sonar created a dangerous problem for ship stability. Because these systems were mounted high on the vessel, warships were becoming top-heavy, and engineers turned to aluminum as a lightweight solution above the main deck. Aluminum superstructures are roughly 30 to 50% lighter than comparable steel types, a fact confirmed by a 1981 survey from the Society of Naval Architects and Marine Engineers. This weight reduction allowed the Navy to pack more weapons and sensors onto the same sized hull, and the non-magnetic properties of the metal offered a secondary benefit by reducing the risk of triggering magnetic mines. Aluminum has a long and strange history in government contracting, dating back to 1884 when a 6-pound pyramid of the metal was placed atop the Washington Monument. While that small tip was projected to cost $75, the final bill ended up being over $250, signaling a pattern of cost overruns that would haunt the material for a century. Before it became a common industrial material, aluminum was so prized that Napoleon III reportedly served the King of Siam with aluminum cutlery, while other guests had to use gold. By the 1960s, the Navy was using it to build the superstructures of the Belknap-class cruisers, but the trade-offs in fire resistance and ballistic protection were never fully addressed. November 22, 1975 marked the date when these engineering compromises turned into a tragedy off the coast of Sicily in the Mediterranean Sea. The guided missile cruiser USS Belknap was performing night maneuvers when it collided with the aircraft carrier USS John F. Kennedy, and ship that would later earn the nickname the Can Opener. The carrier's overhanging flight deck acted like a giant blade that sheared through the Belknap's superstructure, and the impact ruptured aviation fuel lines that spilled thousands of gallons of jet fuel onto the cruiser. Roger Sharp was an electronic warfare technician on the Belknap that night, and he recalled seeing the fuel ignite into what he described as raining liquid fire. Sharp was in the mess hall watching a movie when the collision happened, and he felt the ship lurch as the engines tried to pull the vessel into reverse. Smoke filled the lower decks immediately, and Sharp was forced to flee toward the bow where he watched the aluminum superstructure of his own ship begin to melt. Thermal failure happens much faster in aluminum than it does in steel, and this reality was the primary cause of the Belknap's total destruction. Marine-grade steel holds its structural integrity up to approximately 1,450 degrees Celsius, but aluminum begins to weaken and eventually turns to liquid at only 660 degrees Celsius. The jet fuel fire on the Belknap was so intense that the superstructure essentially dissolved, and the heat caused the metal to drip down the decks like wax. Sailors described the aftermath as looking like the surface of the moon, with the lightweight alloys forming stalactites and stalagmites across the wreckage. Fragments of exploding ammunition showered the rescue boats as the fire reached the cruiser's 3-inch ready storage locker, making it almost impossible for ships like the USS Claude V. Ricketts to get close. The most terrifying part of the disaster was the fire's proximity to W-45 nuclear warheads, which were stored on the ship for use with Terrier anti-aircraft missiles. Because there was a high probability that these nuclear weapons were involved in the inferno, the Navy issued a broken arrow message, the classification used for the most dangerous kind of nuclear accident. It took 6 hours to put out the flames, and by the next morning, 7 sailors on the Belknap and 1 on the Kennedy were dead. Rebuilding the Belknap took 4 years at the Philadelphia Navy Yard, and the ship eventually returned to service in 1980 with a superstructure that featured steel reinforcement. This disaster persuaded the Navy to pursue all-steel construction for future ships, leading to the Arleigh-Burke-class destroyers, which were designed specifically to avoid the calamities witnessed in 1975. However, the reputation of aluminum was further damaged during the 1982 Falklands War, even though the most famous loss of that conflict involved a ship made of steel. May 1982 is often cited by critics as the ultimate proof of the aluminum disaster because that was the month HMS Sheffield was hit by an Argentine Exocet missile. Many news reports at the time claimed the Sheffield superstructure melted and caught fire, yet the Board of Inquiry and Technical Assessments confirmed that the ship's superstructure was made entirely of steel. The actual cause of her loss was a missile impact that severed the high-pressure fire main, which left the crew unable to fight the fires started by the missile's unburnt propellant. While the Sheffield wasn't an aluminum ship, the aluminimophobia of the 1980s was justified by the losses of the Type 21 frigates, HMS Antelope and HMS Ardent. These vessels did have aluminum superstructures, and they suffered from rapid fire spread and structural weakening that made them impossible to save. Technical misconceptions about the Sheffield didn't stop the Navy from returning to aluminum in the early 2000s under a new doctrine called the street fighter concept. Admiral Vern Clark and Vice Admiral Arthur Cebrowski believed that speed is life, and they wanted a fleet of small, fast, and networked ships that could dominate the littorals. This led to the creation of the Littoral Combat Ship program, which produced two radically different designs: the steel-hulled Freedom class and the all-aluminum Independence class Trimaran. Admiral Clark bypassed the normal requirements process to get these ships built, and that rush to production meant there was no formal understanding of how the ships would actually be used. The Independence class was an aluminum trimaran measuring 127 meters in length, and its lightweight frame allowed it to hit sustainable speeds of 44 knots. While it looked like a technical marvel, the ship quickly became a symbol of shoddy construction and poor oversight. Galvanic corrosion occurs when two dissimilar metals are in electrical contact in seawater, and this predictable disaster began to dissolve the USS Independence almost immediately. The ship's aluminum hull was in contact with its stainless steel water jet propulsion units, and because the electrical insulation was improperly installed during construction, the hull acted as a giant sacrificial anode. In 2011, reports revealed that the metal around the water jets was completely gone, and not just rusted, meaning the ship was literally disintegrating in the water. Austal USA blamed the Navy for poor maintenance, while the Navy pointed back at the shipbuilder for the installation errors. Seawater was acting as an electrolyte that facilitated a massive chemical reaction, and the Navy had to spend $5 million on emergency repairs for a ship that was practically brand new. 7 U.S. senators sent a letter to the Department of Defense in 2011 questioning why the corrosion problems were so severe, and the only solution was to install a cathodic protection system to slow down the decay. This was a desperate attempt to fix a problem that should have been solved during the design phase, and it was only the beginning of the program's mechanical failures. Unlike steel, aluminum has no endurance limit, which means that even the smallest recurring stresses from the ocean will eventually cause the metal to fail. By 2022, the Navy confirmed that ships like the USS Omaha were suffering from class-wide structural defects that led to significant hull cracks. These cracks were appearing at ship frames 36 and 45, where the shell plate met vertical flat bars, and the damage was so severe that the ships were placed under strict speed and sea state restrictions. USS Omaha was restricted to traveling no faster than 15 knots whenever wave heights reached 8 feet, which neutralized the only advantage the ship actually had. A warship designed for high-speed transit could no longer operate in a rough sea state, and critics noted that the Independence class might not even be fit for low-end missions like drug interdiction. These structural problems were a direct result of using aluminum for a high-speed combatant that was constantly subjected to cyclic stresses from the water. Internal reports eventually concluded that the littoral combat ship was not expected to be survivable in a high-end combat environment against a peer competitor like China. The Pentagon's chief weapons tester noted that the ships could not maintain mission capability after taking a significant hit, and the modular mission packages were years behind schedule. The remote mine hunting system, which was a core part of the ship's purpose, was plagued by reliability issues and was eventually abandoned. Government watchdogs have labeled the LCS program as one of the worst boondoggles in military history. While the ships were originally intended to cost $220 million, the price per seaframe doubled to over $500 million, and some ships have been mothballed after less than 5 years of service. ProPublica reported that the lifetime cost of the LCS class may reach $100 billion, and for that price, the taxpayers are receiving fewer than 30 ships that have limited combat utility. Early decommissions became a standard part of the program as the Navy tried to cut its losses on ships that were essentially little crappy ships. While the Navy originally planned for a fleet of 55, that number was progressively cut to 32, and the service began shifting its focus back to more capable frigates. By 2024, the Constellation-class frigate was supposed to be the answer to these failures, but that program ran into its own set of delays and design changes. November 25, 2025 saw a massive shift in naval strategy when Secretary of the Navy John Phelan announced the cancellation of the last 4 ships in the Constellation-class program. The program was 36 months behind schedule, and design changes had reduced its commonality with the original FREM design to just 15%. Secretary Phelan justified the decision by stating that the fleet needed to transition toward faster procurement to grow on a more urgent timeline. December 19, 2025 brought the announcement of the FFX program, which is based on the U.S. Coast Guard's Legend-class national security cutter. This is an all-steel design with a steel hull, steel superstructure, and steel bulkheads, and it represents a total rejection of the aluminum experiment. The FFX will displace 4,500 tons and feature a maximum speed of 28 knots, with a range of 12,000 nautical miles that is triple the endurance of the LCS. The Navy aims to have the first hull in the water by 2028, leveraging a proven American-built design to reduce technical risk and production timelines. HII's Ingalls Shipbuilding will handle the construction of these new frigates, which are designed to survive in medium-threat environments. These ships will handle routine missions like narcotics interdiction to free up the Navy's high-end destroyers for primary combat roles. By using a steel design that already operates with the fleet, the Navy can move at a war-footing pace to bridge the growing gap between the United States and the Chinese surface force. December 22, 2025 marked the official launch of the Golden Fleet Initiative at the Mar-a-Lago Club in Palm Beach. President Trump and Secretary Phelan announced a new class of battleships, with the first vessel to be named the USS Defiant. These ships will be roughly 3 times the size of an Arleigh Burke-class destroyer, displacing between 30,000 and 40,000 tons, and they will be built with heavy steel armor specifically for high-intensity combat. President Trump claimed these battleships will be the fastest and largest ever built, and they are intended to serve as a centerpiece of a new nuclear deterrent. The Trump class will carry surface-launched nuclear missiles, hypersonic weapons, electromagnetic railguns, and high-powered lasers. Secretary Phelan described the mission of these ships as reaching out to kill the archers, rather than just trying to swat the arrows from the sky, a reference to the ability to strike deep into enemy territory. USS Defiant is targeted for construction in the early 2030s, and the Navy aims to eventually have a fleet of 20 to 25 of these massive surface combatants. This shift away from small, fragile aluminum ships toward heavy, armored steel platforms represents a generational commitment to American sea power. The Golden Fleet Initiative also includes plans to double ship requests in the 2027 budget, focusing on auxiliary and support ships that are easier to build than complex nuclear submarines. Secretary Phelan emphasized that the era of accepting delays and underperformance without consequence is over. The Navy is now prioritizing speed, scale, and execution, and that includes integrating unmanned systems and artificial intelligence to add mass to the fleet. The goal is to revitalize the maritime industrial base by focusing on ships that can be built quickly and reliably in American shipyards by American citizens. Unmanned systems will serve as a foundation of this expansion, extending the sensor reach of the fleet and absorbing risk without a linear increase in manpower costs. These systems will be paired with the offensive power of the new battleships and the utility of the steel-hulled frigates. To manage this technology, the Navy is deploying the Data Edge Collection Kit, or DEC, which turns ships into learning systems that can collect operational data and retrain AI models on the fly. Fiscal 2027 could see at least 34 new ship requests as the Navy moves at what Phelan calls a war-footing pace. The One Big Beautiful Bill Act has already provided billions for shipbuilding programs to bolster capacity, nearly doubling the annual spend of the previous administration. This surge in funding is directed toward a fleet that is built to take a punch, a basic requirement for any warship that was forgotten during the aluminum era. 50 years of history have proven that speed cannot replace structural integrity. From the molten ruins of the USS Belknap in 1975 to the dissolving hulls of the USS Independence in the 2000s and 10s, the Navy has paid a high price in both lives and dollars to learn that aluminum is a liability in a combat zone. The move back to steel with the FFX and the Trump-class battleships shows that the lessons of the past have finally been institutionalized. Future American sea power is now anchored in the resilience of steel and the mass of a revitalized industrial base. As the Golden Fleet takes shape, the Navy is returning to its roots, building ships that can survive direct hits and project overwhelming firepower. The age of the melting warship has ended, and a new era of armored, lethal dominance has begun.